Hello everyone, this video is brought to you by the Atılım Üniversitesi OpenCourseware project for the course Physics 101. The lecture notes are prepared by Associate Professor Dr. Hüseyin Oymak and video lectures are prepared by Ümit Alkuş. In this video, we will solve one problem in Chapter 11. Two-point particles with masses m1 equals 5 kilograms and m2 equals 3 kilograms are connected to the ends of a rod of length L 2 meters and mass M 4 kilograms. This rod plus particles system is initially at rest on a horizontal plane and free to rotate about a fixed frictionless rotation axis passing through the center of mass of the rod. A lump of clay of mass M3, which is 1 kilogram, collides and sticks to the rod at a point 0.6 meters away from the axis of rotation. A. Find the rotational inertia of the rod plus particles plus clay system after the collision. B. If the rod plus particles plus clay system rotates with an angular speed 3 radians per second just after the collision, what is the speed v of the clay before the collision? The rotational inertia of the rod is 1/12 times capital M times L squared. First of all, we write the given quantities in SI unit. In part A, we find the rotational inertia of the whole system after the collision as I rod plus particles plus clay equals I final equals I rod plus I1 plus I2 plus I3. For I1, I2 and I3, we use this formula. That is, m1 times r1 squared plus m2 times r2 squared plus m3 times r3 squared. Therefore, the rotational inertia of the rod particles clay system after the collision is IF equals 1/12 times capital M times L squared plus m1 times L/2 squared plus m2 times L/2 squared plus m3 times d squared. Now we substitute the corresponding numerical values into this equation. Therefore, we calculate the rotational inertia of the rod particles clay system after the collision as 9.6933 kilogram times meter squared, and it is approximately 9.69 kilogram times meter squared. Since rod plus particles system is initially at rest, their angular momenta are zero by the formula L equals m times r times v times sine theta. But before the collision, that is, initially, the lump of clay, that is M3, is moving. Then its angular momentum is calculated to be L3 equals M3 times R3 times V times sine 30 degrees, which gives a non-zero result. Therefore, the angular momentum of the whole system before the collision is due only to the moving lump of clay. Then we write capital Li equals L3I equals M3 times V times D times sine 30 degrees. And since the net torque on the system is zero, then angular momentum is conserved. This is to say L initial equals L final. we use the expression for angular momentum, which is L phi equals IF times omega F. Then m3 times v times d times sine theta equals IF times omega F. So the expression for v is IF times omega F over m3 times d times sine theta. And we substitute the corresponding numerical figures into this equation. And we finally calculate the speed v of the clay before the collision as approximately 96.6 meters per second. Well, this brings us to the end of the discussion of this problem. Thank you for your attention and see you in the next video.